Software testing teams often divide themselves into two distinct camps: those who rely heavily on manual, exploratory testing, and those who strictly mandate automated, scripted testing. Committing strictly to only one of these methods creates severe blind spots. Automated scripts will blindly pass a functional button, even if a UI glitch makes it invisible to the user. On the flip side, manually testing every legacy feature before a release is too slow to support modern development cycles. To build a reliable application, teams need a hybrid QA strategy that deliberately balances both approaches. Think of scripted testing as a wide safety net designed to catch known regressions. Exploratory testing acts as a magnifying glass, allowing human testers to actively hunt for hidden, unpredictable flaws. Integrating these two methods catches critical edge case bugs before they reach production, while keeping the application's baseline features perfectly stable. Before writing a single test case, you have to evaluate the maturity of the software build you are working with. If a feature is brand new, with a volatile user interface, or if it relies on complex multi-touch gestures and variable network conditions, it requires exploratory testing. Humans excel at navigating these fluid, unpredictable states. Conversely, if you are looking at an established high-volume core path, like a user login or a checkout cart, it requires scripted testing. You can build a consistent workflow by routing new, volatile features into an early-stage bucket for manual review, and sending stable, legacy features into a compliance and regression bucket for automation. Sorting tasks at the start prevents your team from spending hours writing automation scripts for a user interface that will inevitably change next week. For those new features, initiate an exploratory bug bash. This is an unscripted session where testers rely on their intuition to actively stress the software and uncover unexpected behavior. Testers intentionally manipulate the physical variables. They might drop the Wi-Fi mid-transaction, trigger a phone call during loading, or swap between different physical devices to see how the application reacts. Finding a bug during this phase is only the first step. The actual value of an exploratory session relies entirely on how meticulously those bugs are documented. A vague entry stating a button is broken gives developers nothing to work with. A structured framework provides the exact variables needed to replicate the error. Clearly separate the expected outcome from the actual outcome. State exactly what the application was supposed to do, followed by the exact error that occurred instead. Record the specific environment details. Log the operating system version, the browser type, the specific device model, and attach the system logs generated during the failure. Providing this context eliminates diagnostic guesswork. Developers can recreate the exact conditions immediately and write a patch faster. After the initial bugs are patched, the new feature's interface and core logic will reach a stable state. Once the feature behaves predictably, translate those specific actions into a formal, structured document. This spreadsheet shows the standard template for a formal test case. It isolates the necessary data into columns for the test ID, description, expected result, actual result, and pass-fail status. For a valid user login, the description states, enter a valid username and password. The expected result is simply access granted to the user dashboard. Limit each test case to verify a single, narrow core function. If a test checks 5 different variables and fails, you won't know which of the 5 caused the failure. Standardizing these test cases guarantees the test is run the exact same way every time. This consistency provides the mandatory foundation required to transition into automated testing. Take those newly structured test cases and transition them into a dedicated automation suite to lock down the feature. This is the Eclipse IDE workspace. It serves as the development environment where your testing scripts are initialized and housed. By creating a new project here, you establish the foundation directory that will run your repeatable tests. Once programmed, this suite will run your standardized test cases continuously. It will execute autonomously, verifying that established features continue to function correctly as new code is added to the application. Offloading these repetitive functional verifications to a machine eliminates human fatigue and guarantees perfect execution accuracy on every single run. This continuous testing loop mathematically protects your legacy code while freeing your QA team to focus their human creativity on exploring the next new feature. This creates a sequential lifecycle. A new feature undergoes exploratory testing, stabilizes, gets written into a formal script, and moves into automated regression. Operating this dual-layered system results in faster release cycles, lower crash rates in production, and higher ratings in the App Store. Delivering high-quality software requires the human intuition to actively break new features and the automated precision to keep them fixed permanently. Download the testing template linked below to structure your first bug bash and begin building your hybrid testing cycle today.